Hello, good day everyone. My name is Berthold Breit. I'm the founder and director of Renewables Academy RENAC based in Berlin. We would like to give you a bit an impression on what kind of training facilities, training center, experiments we do have here in Berlin, and I want to invite you to join to our small tour in the training center.
One of the most recognizable components in renewable energy is, of course, the photovoltaic panel. This monocrystalline panel has a rating of 285 watts and is built on a mobile stand with adjustable tilt angle so that we can demonstrate with students the effects of orientation to the sun, of tilt angle, and of shading on the various characteristics that define the electrical properties of the PV cell. For that, we will use the same tools that a professional installer or technician will use. We have our reference cell and our IV curve measurement tool, as well as a temperature sensor, all of which we will need to analyze the condition of our PV panel.
So this is one of our PV off-grid boards, and we use this to let students practice themselves electrical installation, so connecting up cables, terminating cables, and as well, of course, understanding the different components. We have here the user manual, which gives the students detailed instructions of how to connect up the system. And then, of course, we have all of the tools and measurement instruments that they need. The multimeter here for measuring mainly the voltage. Then here we have the clamp meter, which you can clip over one of the cables to measure the current flowing through it. And then the main tools which the students need are screwdrivers, larger screwdrivers, electrical screwdrivers, and then, for example, the crimping tool for putting the crimps on to the cable ends when you're terminating the cables. So the important final connection is connecting the batteries to the system. Here we've got our off-grid inverter, our charge controller, and those already are the main components of the off-grid system.
Here we see our exhibit on compressed air and the effect of leakages on the energy consumption of a compressed air system. Compressed air system can be found in almost every industrial sector. Our system here consists of a compressor and a pipe system at which we can control the inlet pressure and the system pressure here, and we have 3 different pipes with 3 different leakages. We will demonstrate this now via one circle of loading and unloading the system. Now the system has a system pressure of 2 bar. We can open one leakage and stop the time it takes to unload the system from 2 bar down to 0 bar again. Knowing the power consumption of the compressor and the time it takes to load and to unload the system, we can calculate the energy losses which occur due to the leakage in the compressed air network.
We're going to see the aerodynamics of a wind turbine with the help of this small model. First of all, I will explain a little bit of all the components we are using here. We have this blower that simulates the wind speed. We have our tiny wind turbine, in this case with 3 blades, and the profiles are curved. Here is a small generator. We have our tower, and we can also connect our wind turbine to all our measurement devices. And we can measure right now the power output of our wind turbine. We can read now the voltage and the current. And by multiplying both of these values, we get the power output of the generator.
This training rig is a miniaturized version of a grid-connected PV system. Students will identify components such as the PV panels or the PV panel simulator, which they will connect through either a fuse box or directly to the inverter. This then connects to the distribution board in our home, which we can find in the basement, and connects us to the various loads such as lights, washing machines, refrigerators, and computers. This distribution board then connects outdoors somewhere to our POC, the point of connection, to the larger national electrical grid. This last component here is a monitoring system, which we might be able to access remotely, and uses data from the energy meter here at the point of connection, the inverter, and at our distribution board to establish the difference between the power produced by our system and that needed by our loads. This energy can be reimbursed by the national grid in terms of feed-in tariff or net metering to give us some income or payback for this system.
So this is one of our solar thermal training rigs. It's a forced circulation system, which means that we have a pump which is driving the circulation and pushing the water from the collector where the sun heats it up down to the store. So the main components that we have in this system are the collector at the top, the storage tank which is around the back of the rig, then the pump which is in this unit here, the solar station, and the controller which controls when the pump comes on and off. What we also have here are two temperature gauges, one which is reading the temperature of the hot flow coming from the collector, and the other the temperature of the cool return going back to the collector. So we use this rig during our solar thermal training sessions to allow the students to work with the real system. We use this as a fault finding rig, so we build various faults into the system and the students have to find them. We can also use this as a commissioning rig, so the students go through the whole commissioning process from having an empty system through to having a filled, fully operational system.
Here we see our exhibit on thermal insulation, an application which you could imagine in a heating system in a residential or non-residential building, but also in industrial applications, for instance in the process industry. See here an electric heater with which we can set the temperature or the flow temperature of the water circulating inside the pipes. At the back we have a circulation pump to circulate the water, and we have 4 different pipes. At the top we got a pipe which is not insulated at all. The second pipe is insulated with a rubber insulation, and the third and the fourth pipe, they are both insulated with a mineral wool. In contrast to the third pipe, at the fourth pipe the instruments are not insulated. By an infrared camera, the temperatures of different surfaces can be made visible. And here we see the second and the third pipe in comparison, and the infrared camera highlights the heat losses occurring at the second pipe are higher than at the third pipe.
So, I hope you enjoyed the small tour through our training center. I want to thank you again for your interest in our small video, and I wish you all the very best. Bye-bye.